Dear students, this is 58th audio about 12th standard mathematics, and from this audio I will start discussing paper 1 of standard 12. Obviously all the chapters I am not going to discuss because considering the nature of these audios being audio lecture, it's not possible to write on the blackboard and explain, and so some chapters which you can easily understand just through audio clips I will be able to discuss, and that is what I am trying to do. So I will start with the very important chapter called pair of straight lines. Right. Now when you consider this particular chapter, lot of things that you have studied in standard 11 about straight line will be useful to understand the ideas in this chapter. You have studied different forms of the equations of the straight lines, and in this particular topic we will see how the straight lines together can be represented by a single equation. Right, that is why the name of the chapter pair of straight lines. It is not just one straight line, it's a pair of straight lines, and whenever you represent pair of straight lines by an equation, okay, then it is called as the joint equation of the lines, right? And this joint equation of the line is always a second degree equation in x and y. Before going to that chapter, what you should know, that I will tell. The first thing is you should know certain formulae that you have done previously. The first is distance between the 2 points. If you have given say one point capital A and coordinates of that point are suppose x1 comma y1, and another is B, capital B, x2 comma y2, then what is the distance between these 2 points? DAB, or in short we can write mod of AB. Mod is used to represent distance between the 2 points. Mod is used in many places, and you should understand the use of mod by the context. Whenever I am saying mod of minus 5, it is 5. In that case, that mod notation is used for absolute value. Here it is used as a distance. What is the formula? Root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Okay, then you have studied section formula. That means suppose you have 2 points, say x1 y1 and b x2 y2, and there is the point P which divides this line segment AB internally in certain ratio. Say that ratio is m:n, right? Then what are the coordinates of the point P? The coordinates are given as mx2 plus nx1 upon m plus n. This will be x coordinate of that point, and another will be y coordinate, will be same, my2 plus ny1 upon m plus n. Now this is the formula for internal division. Similarly, there is a formula for external division. That means suppose AB is a line segment and P is the point which lies on the extended line segment AB, extended after B or extended before A, and that P lies on that. Then we will say it is not C, it is not the point in between A and B. When the point P lies between A and B, then it is internal division. Here it lies outside A and B. Okay, it may be to the left of A or it may be to the right of B. And in that case, the formula, that means when P divides AB externally in the ratio m:n, then the formula for P will be mx2 minus nx1 upon m minus n. and y coordinate is my2 minus ny1 upon m minus n. So in case of internal division there is a plus sign, and when it is external division it is minus sign. Otherwise rhythm is same, mx2 plus nx1 upon m plus n in case of internal division, and in case of external division it is mx2 minus nx1 upon m minus n. So this is how you have to remember it: internal plus sign, external minus sign. Okay, then you have a midpoint formula. What is that midpoint formula? It means the ratio is 1:1. Whenever midpoint always lies between A and B. You cannot have midpoint outside a line segment AB. So it is an internal division, and as it is midpoint, right, when P is midpoint of AB, the ratio in which P divides AB is 1:1. And so the formula for that comes out to be x1 plus x2. If A is x1 y1 and B is x2 y2, then midpoint formula is x1 plus x2 upon 2, y1 plus y2 upon 2. Then next we have to know centroid formula. Right, you know the point of concurrence of the medians of the triangle is called centroid of the triangle. From the geometry of vectors, you know, or we will do that afterwards. But whenever you draw median of the triangle, medians, there are three medians. Suppose your triangle is ABC, then you can draw median through A. Median through A is what? It is a line segment which joins A and midpoint of opposite side BC. So when you draw all the three medians, they pass through unique point, and that point is called as the median. Okay, so also in other words, what happens is that median, suppose AM is the median, that means M is midpoint of BC, then AM is the median, right? Then centroid is the point which divides median internally in the ratio 2:1. And then with using that section formula, calculating midpoint by using midpoint formula, we can calculate coordinates of M, because M is midpoint of BC. So you know coordinates of B and C. So you can easily calculate midpoint, and then join AM, that will be a line segment, and this centroid is the point which divides median internally in the ratio 2:1. So by using section formula and making calculations, you can see that centroid of the triangle ABC, where A is x1 y1, B is x2 y2, C is x3 y3, will be x1 plus x2 plus x3 upon 3, which will be the x coordinate, and y1 plus y2 plus y3 upon 3, it is a y coordinate. So all these points related with triangle, that means there is something called in center also, centroid, all such things, their formulae you should be aware of. What is in center? See, it is the point of concurrence of the bisectors of the angle of the triangle. Right, whenever you take a triangle ABC, there are three angles, right? A is one angle, B is another, C is another angle. Now when you consider bisectors of these angles, bisector of angle A, bisector of angle B, and bisector of angle C. Now these angle bisectors, they are concurrent. And what is meant by concurrent? See, whenever two lines which are not parallel, they definitely intersect at a single point, but third line also when passes through that point. Okay, when three or more lines pass through a single point, then that point is called point of concurrence. Okay, so now this you should be aware of. So the point of concurrence of the bisectors of the angle of a triangle is called in center of the triangle. Now suppose you have A, capital A, x1, y1, capital B, x2, y2, capital C, x3, y3 are the vertices of triangle ABC with the sides BC, CA and AB. Right, as ABC, as their lengths, suppose I take, see, generally in case of triangle, what is the terminology? If the point is capital A, opposite side is BC, its length is considered as small a. If the point is capital B, opposite side is AC, its length is considered as small b. And if the third point is C, opposite side is AB, its length is considered as small c. With all these notations, right, with all these notations, in center of the triangle is given as AX1 small a, this is small a, AX1 plus BX2 plus c x3 upon a plus b plus c, this is x coordinate of the in-center, and a y1 plus b y2 plus c y3 upon a plus b plus c is y coordinate of the in-center. Okay, so these are special points, right, about the triangle, and we should be aware of their definitions and what those points are, where those points are in the triangle, and what is the formula. If I know the coordinates of the vertices of the triangle, then what is the formula which will give me the in-center, which will give me median of the triangle, which will give me median is not a point, sorry, centroid of the triangle, etc. All such things you must be aware of. Then very important concept is the slope of the line. Right, now there is one, all these things already I have discussed in standard 11, but still as a part of this chapter, because in this chapter also we are going to use these concepts invariably. So if you take any line, here I am considering, or we are studying actually two-dimensional geometry. So you have x and y axis, and if you take a line, right, if it has inclination theta. Now what is this inclination? Inclination means angle made by the line with positive direction of x axis. That is called inclination. And if theta is the inclination of the line, and if theta is not equal to pi by 2, then tan theta is the slope of the line. Right? If theta is pi by 2, tan theta is not defined. Tan 90 is not defined, as you know. Okay, so if theta is not equal to pi by 2, then inclination of the line is the angle made by the line with positive direction of x axis. If that angle is theta, then tan theta is the slope of the line. This you must be knowing. Now when you take a line which is parallel to x axis, what is the slope? It is 0. And the slope of the y axis, or if you take any line which is parallel to y axis, then its slope is not defined, because that line makes angle 90 degrees with positive direction of x axis, and tan 90 is not defined. So slope of x axis or any line parallel to x axis, it may be above x axis or below x axis, its slope is 0. But when you take a line parallel to y axis or y axis itself, y axis is also a line, right, its slope is not defined. This we should be aware of. Then if you have a line which passes through the 2 points, say one point is say a x1 comma y1, and another is say b x2 comma y2, what is the slope of this line AB, line passing through these points A and B? It is y2 minus y1 upon x2 minus x1. That means we have to take difference of y coordinates divided by difference of x coordinates. So that is the slope of the line. But if the line is in general form, what is the general form of the line? It is ax plus by plus c is 0. This is a linear equation. Ax plus by plus c is 0 is called as a linear equation in two variables x and y. Right? Why it is called linear? Because the index or power of x and y is 1. If the power of x and y is 2, it is quadratic. If it is 3, it is cubic equation. Equation of the line is a linear equation in two variables x and y. Ax plus by plus c is 0. And if this is the equation of the line, what is the slope of the line? Minus a upon b. Okay. Now, if you are given two lines, say slope of one line is say m1 and slope of another is m2, right? Now these two lines will be parallel if and only if m1 is equal to m2. These two lines will be perpendicular if the product of the slopes is minus 1, right? Now this we should be aware. Next thing is any equation of the first degree of the form. If I take any equation, ax plus by plus c is 0, where a, b, c are constants, always represents a straight line, right? At least one of a and b must be non-zero. That is a condition, because if both a and b are 0, it's not a linear equation in x and y. It will be just constant, and that c cannot be equal to 0 unless c is 0. And that is why you should be aware that if anyone asks you that is ax plus by plus c is equal to 0 represents a straight line, Answer is this, that if both, at least one of A and B must be non-zero. If both A and B are zero, it cannot represent a straight line. Okay. See, if x plus by plus c is 0 is equation given to you, and suppose A is 0, then it is of the type by plus c is 0. That means then y is equal to minus c upon b. So y is equal to constant. It is a line parallel to x-axis. Okay. Another thing, that if ax plus by plus c is 0 is given, and you are told that b is 0, then it reduces to ax plus c is 0. It means it reduces to x is equal to minus c upon a. Now it is x is equal to constant, so it is line parallel to y-axis. Okay. So equations of the lines are very important. What is equation of x-axis? It is y0. What is equation of y-axis? It is x is equal to 0. If you have a line parallel to x-axis, then its equation is y is equal to b. If the line is parallel to y-axis, its equation is x is equal to some constant, right? Some x is equal to k. Then there are various equations, types of the equations. One is slope intercept form. It is y is equal to mx plus c. What is m in that? Slope. What is c? Intercept on y-axis. Then double intercept form is there. Means if line makes intercept a on x-axis. Now when you say line makes intercept a on x-axis, that means line passes through the point a comma 0, and suppose it makes intercept b on y-axis, it means it passes through the point 0 comma b. If this is the line, then the equation of the line is given as x upon a plus y upon b is equal to 1. Then you have slope point form. That means when line passes through the point, say x1 comma y1, and slope of the line is m, then what is its equation? Y is equal to actually it is y minus y1 is equal to m into x minus x1. That is the slope point form. Then there is a 2-point form. That means when line passes through, say one point is say x1 comma y1, another point is x2 comma y2, then what is the equation of line? It is y2 y minus y1 upon y1 minus y2, okay, is equal to same x minus x1 upon x1 minus x2. There is also normal form of the equation of the line, where length of the perpendicular when you draw from the origin to that line, and suppose that length is p, okay, and alpha is the angle which the perpendicular makes with positive direction of x-axis, then equation of that line is x cos alpha plus y sin alpha is equal to p. Okay. Then there is another formula that you have done, and it was angle between the two lines. The angle theta between the two lines, when the slopes of the lines are m1 and m2, is given by tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. Tan theta is equal to this, right? Then there is another concept which you have done, that it is length of the perpendicular from the point on the line. So whenever the point lies on the line, length of that point from that line is 0. But if point is not on the line, and if you drop perpendicular from that point on the line, then what is the length of that perpendicular? This is one of the things. So if that point has coordinates x1 comma y1, and suppose the equation of the line is ax plus by plus c is 0, then the length of the perpendicular from the point x1 comma y1 to the line ax plus by plus c is 0 is ax1 plus by1 plus c upon root of a square plus b square, mod of this. Why we take mod? Because it is a length, it cannot be negative. Length can be 0, but 0 or greater than 0, it cannot be negative. That is why mod is considered. And whenever two lines which are parallel given, now you should understand that when two lines are parallel, what will be the nature of their equation? Ax plus by part will be same, and constant will be different. If constant is also same, they are coincident lines, then the distance between those two lines is 0. But if the equations of the lines are ax plus by plus c1 is 0, and another equation is suppose ax plus by plus c2 is 0, then the distance between these two lines is given by mod of c1 minus c2 upon root of a square plus b square. This is the distance between two parallel lines. And finally, you must know what is the point of intersection. If the two lines are given and if you are interested in finding the point of intersection, what is done is solving those two equations. These are two linear equations, so you know how to solve the two simultaneous linear equations. And so the point of intersection is the solution of the two equations. When you solve those two equations, you get the point of intersection. So this is all the prerequisite that you know for learning pair of straight lines. I hope you enjoyed this audio. Thank you.